Late afternoon over the Pacific. The ocean peers clong, almost indifferent. USS Kitty Hawk, move forward, stay speed. Its massive hull displayed a mere 8,000 tons. Aircraft chains securely off the deck, prepared for thinner feet-runs operations. Below that, radar and navigation systems report normal maritime conditions. Far beneath the Pacific, tectonic plates remain locked under decades of accumulated pressure. Depth, stress overcomes friction, and a megathrust earthquake begins. The seabed rises abruptly, displacing billions of tons of water above it. A long wavelength pulse spreads outward through the entire water column. Satellites detect subtle surface elevation changes across the Pacific Basin. Pressure buoys register measurable vertical displacement. Wave speed exceeds 700 kilometers per hour. Initial seismic alerts reach naval monitoring systems. The ocean, the tsunami does not resemble breakaway. It moves through the full depth of the ocean, from seabed to surface. New data shows rising amplitude beyond early projections. Interaction with mid-ocean ridges begins compressing wavelength. Compression increases vertical height. Updated models show potential intersection with the carrier's path. Time to arrival estimates begin narrowing. Secondary inspections secure every aircraft against unexpected motion. Ballast redistribution loads the ships under dry. Propulsion systems stabilize output for control maneuvering. The carrier begins a landing bow first toward projected wave direction. Ahead, the horizon begins to thicken suddenly. Seismic instance a major megathrust event. Seabed displacement forces upward motion across vast water columns. In deep water, wave height remains broad and gradual. The USS Kitty Hawk maintains 18 knots cruise speed. Longitudinal calculations begin in naval modes. Wave compression intensifies as energy crosses elevated seabed structures. Recorded displacement now exceeds 5 meters in deep water. Revised projections narrowed the estimated arrival window. The sea surface still appears calm to the naked eye. But the entire ocean depth is moving. It's one math. Naval engineers calculate potential hugging forces along the hull. All loose machinery is locked into reinforced transit positions. Ballast redistribution optimizes the carrier's stability margin. Propulsion output is adjusted for precise directional control. The bow aligns directly toward the approaching energy front. A distant rise becomes perceptible
against fading sunlight.
Marine radar shows little signature of the approaching wave. Altimetry confirms crest height exceeding 6 meters. Personnel operate with calm procedural discipline. Structural monitoring systems begin continuous data logging. Light fades as the ocean thickens out. A horizon now appears subtly ovate. A jangle increases gradual beyond routine motion. Low-frequency vibration travels through steel compartments. Incline reaches 6 degrees and continues rising. The ship collides a moving hill of wire. Night operations lying engaged across the flight deck. Steam pressure and electrical loads remain stable. The sea no longer appears level. Maximum ascent lahi air cord. Pogging forces stretch upper deck beams. Bending moments approach high operational thresholds. Steel flexels within elastic tolerance. The carrier nears the way's apex. The ship reaches peak elevation. For breeze known, a deck feels low. The ocean now drops away and ascent begins on the lee face. Tagging stress shifts toward the keel. Electrical systems compensate low titles. The stern lifts as buoys shift. Expanding values are recorded. No pat, only control mitered. The trough appears deeper, here's deeper than predicted. Ike slides down a vast water flow. Internal resonance remains below critical frequency. Stress approaches upper safety margins. Alust equilibrium prevents excessive trim. Gewake die moon ja the foot. The secondary quest approaches of lower amplitude. Pitch increases but remains controlled. No equipment displacement is observed. Our Jerivson remains uninterrupted. The ocean slowly returns toward baseline. Primary wave trains is past. Engineers analyze record structural lows. I'll take a lecture, remains elastic rains. Weld seams show no propagation cracks. The curing systems held without failure. No arc faults are detected. Propulsion alignment remains true. Secondary oscillations weaken steadily. Morning light approaches across the visual survey again in daylight. Deck camber remains within tolerance. Stress readings normalize completely. The gradually remise optimize. In deep water, tsunamis behave as pressure systems. Near shore, amplification becomes destructive. Here in deep basin water, survival was engineered. Operational readiness is gradually restored. The Pacific appears unchanged once more. But data confirms a rare and powerful encounter. With daylight, the scale of what occurred becomes measurable through data. Accord bendings are compared against structural design causes. Every wild scene is checked for microscopic fracture lines. Deck surfaces are examined in systematic quadrants. Landing gear mounts show no shear displaying. Bulkhead alignment remains precisely with equilibrium dates. Turbine shafts rotate without abnormal vibration signatures. Balanced equilibrium remains unchanged after peak stress. The hull plating shows no visible distortion along the waterline. During ascent, hogging forces distributed across reinforced girders. During descent, sagging forces reversed compression patterns. Both stress phases remained below ultimate yield thresholds. In deep water, tsunami energy spreads rather than collapses. Destructive amplification occurs only in shallow coastal regions. Precise bow alignment reduced torsional roll risk. The crest was broad, elevated, but not breaking. Steel flexed elastically and returned to original geometry. Operational review confirmed full mission capability. The Pacific resumes ordinary rhythm. The tsunami continues toward distant coastlines. Signs. Systems operate as well nothing extraordinary occurred. A base sensors captured every microsecond of stress. Deep and reached 80% below maximum tolerance. Control lost maintained optimal riding mode. Power generation never dropped below operational minimum. Aircraft mass contributed, stabilizing distributed weight. Beneath the surface, buoyancy forces equalized gradually. Load distribution remains symmetrical along the longitudinal axis. Every measurement is logged for engineering archives. Morning light reveals no visible warping. Unlike storms, tsunami motion courth over warm periods. Wave period measured nearly 20 minutes. Long period displacement reduces capsizing probability. Being forced girders absorb distributed bending energy. Rotational alignment remains perfectly centered. Redundant systems stood prepared but unused. To the human eye, the sea appears unchanged. Far away, coastal regions prepare for impact. All watertight seals remain intact. All watertight seals remain intact. In deep basin waters, survivability was engineered. Elastic deformation allowed temporary flex without fracture. Ogging tension concentrated along the upper deck. Sagging transferred compression toward keel structures. Post-event recalibration confirms baseline integrity. Mechanical resonance remained below critical harmonics. Secondary wave trains fade into ordinary swell. Surface signatures return to routine maritime patterns. Command decisions relied on physics, not assumption. A broadside encounter would have increased torsional stress. Improper alignment to amplify Roman. Master long is Mac guarantee survival at sea. The distribution of force hones to endurance. Center of gray management Azur's stability margins. Tsunamis move as food depth processors. I had kilometers of water shifted during displacement. The origin remained far below human visibility. Data provided the only early warning. Palm procedure replaced panic. Aligned trend. Alignment transformed force into manageable motion. Vertical displacement replaced lateral instability. Stress curves flatten as equilibrium returns. Operational tempo resumes gradually. Nature shows little evidence of prior appeal. Systems remain within engineered tolerances. Buoyancy equalizes across the full displacement bar. Design redundancy safeguards against rare extremes. All findings are archived for future modeling. Energy continues across the Pacific Basin. The vessel remains mission capable. floating city, tested by planetary motion. In deep water, scale can be deceptive. 14 meters spread across kilometers. Plastic steel absorbs and releases strain. Measured ballast shifts improved riding moment. Turbines sustained stable rotational output. Securing systems bore load without failure. Ultrasonic scans detect no fracture propagation. Thermal readings show no abnormal hotspots. The ocean returns to apparent calm. Elsewhere, coastal shallows will amplify energy. Reduced depth compresses wavelength dramatically. New shore, destruction Kanzazul. Here, deep war, la Saval. Engineering anticipated extreme possibilities. Lessons are reviewed and documented. Heat stress remained below critical threshold. The hook appears unchanged once more. Yet beneath, memory of motion persists. Human engineering met planetary force. Flexibility prevented catastrophic. Pressure systems move unseen below the surface. Monitoring continues long after danger passes. Stability is calculated, not assumed. Data now strengthens future preparedness. The vessel remains unbroken. The ocean has no visible trace. And across the entire ocean basin. And one ship endured through design, physics, and precision. Hours after impact, operational systems remain fully functional. Internal girders show no permanent deformation. Digital logs confirm elastic recovery across all stress zones. Proportion output remains balanced and uninterrupted. Alice distribution holds optimal center of gravity. Surface infection reveals no structural warping. Aircraft remained locked through maximum incline. Hogging forces were absorbed within safety margins. Sagging stress redistributed across keel reinforcement. The Pacific surface appears deceptively norm. Wave energy continues outward across vast distances. Coastal regions face amplification beyond deep-water behavior. Reduced depth forces dramatic vertical rise.
Deep basin waters.
Motion remains graduate. Offerth line minimize Korsnero. Longitudinal reinforcement distribute load evenly. Metal joints show no fracture propagation. Power systems maintained uninterrupted supply. Rotational alignment remains within microtorus. Every data point is archived for future modeling. Nature resues ordinary rhything, without visible trace. Any thuffy, buoyancy forces equalize slowly. Stress curves return fully to this line. A beaten rainess transitions to a T-watt. Long period waves are fundamentally and storm swells. Short period storms create rapid oscillations. Tsunamis produce sustained vertical displacement. Elastic flats prevents catastrophic fracture. The vessel continues forward without restriction. Tie-down systems show no elongation. Internal water mass remains evenly distributed. Vibration signatures fall below operational thresholds. Surface radar returns to standard Varicon pattern. The ocean basin absorbs and disperses immense energy. Origin of force lay far beneath visibility. "5,000 meters of water shifted above the rupture. Even massive vessels are small against planetary systems. Precision seismicum ensured survivability. Redundancy transforms force into manageable stress. If daylight, 4 high-heel clearance is granted. Mechanical signals. Mechanical systems show no delayed anomalies. View confirms structural integrity. Pacific meals no visible Earth. Far away, shallow shelves will magnify remaining energy. Here in deep water, survival is governed by thick. Distilled buoyancy, preserved equilibrium. Peak loads remained within calculated tolerances. Mass, alignment, and engineering determined outcome. The encounter demonstrates resilience through design. Entrepreneur girders absorbed bending forces. Center of gravity management reduced instability risk. Wave energy continues beyond this vessel. Human discipline matched natural scale. Pistons remain within calibre tolerance. No displacement occurred during peak incline. Full depth pressure defines Tsunami. Context attune a stroke of angel. Location alignment ensured survivability. Measured response replaced reactionary impulse. Recorded data strengthens future naval models. The sea offers no visible evidence of stress. Point forces equalized gradually after passage. Rotational systems show no imbalance. Voltage fluctuations remained within safe bounds. Internal stability never crossed critical threshold. Morning confirms structural continuity. The ocean absorbs disturbance with scale. Restriction. Inspection protocols conclude successfully. Enforcement planning anticipated extreme load scenarios. The water column settles into equilibrium. Energy has crossed an entire ocean basin. Navigation returns to routine monitoring. Standard procedures resume across all compartments.
Steel
remains unbroken. The horizon is level once more. Scale defines perspective open water. Minutes, bending forces tested structural limits. Control ballast permitted exceed true. Mechanical resonance never reached critical frequency. Discipline maintains stability throughout. On returns, without visible scot. Rudder system keys beyond sight. Engineering margins ensures viability. Mass alone was not the deciding factor. This ending wave physics shaped response. In deep war, force becomes measure. Elastic flexibility preserved structural integrity. All propulsion systems remain aligned. Gravity remained autumn. The continued side mission. The Pacific reveals no trace of upheaval. A floating city endured planetary motion. Data now informs future preparedness. Human engineering met natural scale with precision. And through alignment, calculation, and design, the USS Kitty Hawk remained unbroken.